Welcome to Archiversity online classes. In this lecture, I am going to explain you the concept of one sample chi-square test for goodness of fit. Chi-square test is the most common non-parametric procedure used in survey research. I will show you how to calculate, analyze, interpret and the applications of chi-square test in this lecture. Calculation part is done with the help of IBM SPSS statistics. The chi-square test of goodness of fit is one of the most common non-parametric procedure. So in one sample chi-square test, what is that we do is we try to assess the extent of agreement between observed frequencies and expected frequency. Observed frequency is your data collected on a nominal scale. You can call this as a nominal data, and expected frequencies are calculated with the help of a nominal scale data. So here the procedure is that the chi-square test evaluates whether there is a statistically significant difference between observed scores, that is observed frequencies or responses, with expected or hypothesized responses or scores. To perform a chi-square test, the assumptions that we need to look at is, one is the data are from a randomly selected sample. So random selection, random sample is one of the criteria. Second is the responses are independent and no cells has fewer than 5 expected frequencies. That is, no cell should have a frequency less than 5 responses. So it is very essential to see that all these three assumptions are met before running a chi-square test. So in a chi-square test, the hypothesis that we frame is that there is no significant difference between observed frequencies and expected frequencies. So this is our null hypothesis. Whereas an alternative hypothesis is that there is significant difference between observed frequencies and expected frequencies. Now, how is it we are going to interpret the result of a chi-square test? So to interpret the result, we look at the chi-square value. Now here a small difference in chi-square value, that is observed and expected frequencies, will lead to a small chi-square statistic. And a large difference between observed and expected indicates large chi-square statistic. So chi-square is denoted like this, chi-square. So here if you have a chi-square value of a large chi-square value, then we can say that the difference between observed and expected frequencies is very high. Now here, if you find that there is a difference, the difference is very large, and if your variable has got more than 2 categories, then you need to do a follow-up test. When we say that a variable and categories mean, variable is a question that you ask. Let us say students specialization in MBA. So this is a question. So here this is the variable, that is a student specialization is a variable. Under this you will have a different categories, like finance is one category, marketing is another category, HR is another category, operations is another category. So these are the categories, and we collected responses based on the categories and a particular variable. So here in this lecture I will show you how to calculate this chi-square test using SPSS. For that purpose I choose 2 examples. Now one is, this is the first example. A university intended to know which factors influence employee retention. Below question is asked. So here the question is that what makes you continue in a current job? When we are saying a continuation in a current job, we expect that it is a retention. And here we have 4 options. So salary, career growth, nature of work and work culture. That means your continuation in the job, or we can say that loyalty or retention is a variable, and this variable is measured on 4 items, that is a salary, or 4 categories: salary, career growth, nature of work and work culture. So this is a nominal scale, and data you get is a nominal data. So as you have a nominal data and a categories, then you can run the one sample chi-square test. So I'll show you this. So here we have an SPSS data sheet. Now loyalty is a variable name which is given here, and values. So here you have values. 1 is salary, 2 is a career growth, 3 is the nature of work, and 4 is the work culture. And in a data view, you can find the data, the observations here. So to run a one sample chi-square test, what is that you need to do is go to menu command and from menu command click on analyze. And once you analyze this, then go to a non-parametric tests. So here you have a non-parametric test, and from the options that are available for in a non-parametric test, choose legacy dialogues, and in legacy dialogues you will have a further test. So here the first one is a chi-square test. Select this one by clicking on this. A new window will open with a chi-square test options. So select the variable and right click on the arrow here. So then click on this arrow, then expected range, get data from the data, keep this intact, and expected values, all categories equal. If you have any hypothesized value, then you can change this one values and you can enter the value here. But for now we consider that all categories have a equal expected values. Then click on exact. So here click exact, then click on continue. Then you have options here. So in options select the descriptives. If you wish, you can also select a quartiles. Then click continue. And finally click OK. And chi-square test result is presented in output document. Here you can see the descriptive statistics. Number of observations are 378, or responses we can say 378 responses, and a mean value median. So standard deviation are here. Now look at the frequency distribution. Chi-square test is based on a frequencies. So here what makes your current job, your frequencies, you have 4 items: salary, then career growth, nature of work, and work culture. These are the 4 categories, and for each category you can see the observed n values, that is responses, and expected responses. So expected response is 94.5, whereas for salary it is 169, for career growth it is 60, and you have a residuals here. Then look at the test statistics. So here test statistics, look at the degrees of freedom. Degrees of freedom is 3, that is total number of rows minus 1. So you have 4 observations, 4 minus 1 is 3 is your degrees of freedom. Then your probability value is 0.00, which is less than 0.05. Based on the significance value, we say that the null hypothesis is rejected, in the sense there is a significant difference in observed values and expected values. So this is the output of this particular statistical test. As you have 4 categories, that is categories more than 2, then you can do a follow-up test, in the sense to check that whether any of these 2, that is the salary and the nature of work, is influencing other 2 categories. So for this a follow-up test is required, but for now we'll stop here. So here we can conclude that there is a significant difference in observed frequency and expected frequency, and you can also see here that majority of the employees tend towards salary and nature of work. This is one example, and we will go with the second example here. So here a mobile manufacturer recently launched a mobile phone, and to market their product they followed an integrated marketing communication approach. We can say that in simple terms IMC, and by using a different media, that is advertisement, word of mouth, hoarding, social media, and family and friends. Now they wish to know how actually the awareness has been created to the customers. For that purpose, what they did is, whenever the customers came to or visited the store to inquire or buy a mobile phone, they posed this question, and the values are tabulated here. I'll show you. So here is the awareness, and the values are here. So advertisement, word of mouth, and hoarding. Now we want to see that whether all this, in the sense whether all these have a equal importance, or is there any difference in the observed frequencies and expected frequencies. For that, again from menu command, click on analyze, then non-parametric tests, legacy dialogues, chi-square test. So as here, how did you come to know is the variable, and click on this right arrow, then keep the expected range and expected values intact, then click exact. So click exact here, click continue, then from options choose the descriptive and quartiles, click continue and click OK. So the results are presented in output document. So here you can see the total number of respondents are 220, and your observations are here. For advertisement 41, word of mouth 32, hoarding 20, social media 90, and family and friends 37. Alright, and there is residuals values are also here, and look at the chi-square value. Chi-square value is 65, which is a high, which says that there is a difference between observed and expected frequencies. And look at the significance value, which is less than 0.05. We reject the null hypothesis. In the sense, there is a significant difference in observed and expected frequencies. As you can see that social media is one which has got a positive residual and others has got a negative residual. And as you have a categories, 5 categories, you can perform a follow-up test to see that whether the social media is one unique factor which actually created a more awareness among the customers. So this is how you need to run one sample chi-square test to check whether there is a statistically significant difference between observed values and expected values. And if you find there is a significant difference in observed values and expected values, you need to perform a follow-up test. If there is no, then you can conclude that all the 5 categories are having a 5 categories or 4 categories of the same variable or having uniform distribution. Thank you for listening to the lecture.